Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Good morning and good day, everyone. It is a pleasure to welcome respected speakers, delegates, and participants to the International Conference on Computer and Information Sciences, or Iccoins 2020. The Iccoins 2020 conference aims to discover the sustainability impact and challenges of Industry 4.0 with its main pillars such as the Internet of Things, big data analytics, cyber physical systems, and cloud computing on the developments of digital technologies and solutions for sustainable future. Thank you for tuning in to our Iccoins 2020, organized by the Computer and Information Sciences Department, UTP, and co-organized by the University Tunku Abdul Rahman, Utah, Perak, Malaysia, Hamdard University, Pakistan, and Universitas Muhammadiyah Prof. Dr. Hamka, UHAMKA, Indonesia, with the theme Sustaining Tomorrow with Digital Innovations. We have received around 150 papers from all over the world, and 75 papers finally have been accepted and will be presented in 4 different tracks throughout these 3 days of conference. The tracks for our conference are computational intelligence, cybernetics, software engineering and applications, and finally, informatics. In this conference, we're going to have 2 prominent speakers as our plenary speakers. They are Datuk TS Dr. Haji Amiruddin Abdul Wahab, the CEO of Cybersecurity Malaysia, and Dr. Etiken Kandasamy Karupia, the Director of Developer Ecosystem at NVIDIA Southeast Asia, who will be sharing their insight, knowledge, and wisdom on the most recent innovations and concerns as practical as challenges in the developments of digital technologies and solutions for sustainable futures. During this virtual conference also, you will be able to explore the following features in the virtual ESCON 2020. First, the virtual exhibition booth where you can actually interact with our exhibitors, the resource gallery where you can download all the materials that have been uploaded onto the platform, virtual tour where you can actually get to know our university better. We also have the integrated gamification functions. Here, we encourage you to be proactive, especially to gain more points. And finally, the live support in using the platform. Please feel free to ask and seek clarifications if you actually have any problems. I hope that in this conference, you'll be able to forge connections, strengthen networks, and gain benefits from the conference. Finally, I would like to say thank you to all the paper presenters and participants. We value your contributions and active participations in this conference. Thank you to our plenary speakers, Datuk TS Dr. Amiruddin Abdul Wahab from Cybersecurity Malaysia and Dr. Etiken Karupia from NVIDIA. Our technical sponsors, IEEE Computational Intelligence Malaysian Chapter, our conference co-organizer, Utah, Hamdard University, and UHAMKA, all the reviewers and the organizing committee members, as well as our postgraduate volunteers who had been working so hard to make this conference a success. May Allah Subhanahu wa Ta'ala reward you greatly for your good efforts. Let's be part of one of the largest congress in the world and have an enriching, edifying time in Iccoins 2020 and ESCON 2020. Thank you and Assalamualaikum warahmatullahi wabarakatuh.
Okay. Hello. Hello, can you hear me, the presenter and the listener? Welcome.
Can hear you.
Okay, welcome to ISCON 2020 and also welcome to ICCoin 2020. Together with us today, we have 7 speakers, or 7 presenters. And we will start with Pradeep Naulia. Are you here?
Yes, I'm here.
You're
That's
here.
me.
All right. Okay, good.
Good
My name
morning.
is Camille. Actually, I'm the coach. I'm the chair for this session. I'm covering Dr. Izzaddin, which he's supposed to be here, but he couldn't make it, so I will cover him. You are given maybe around 5 minutes for the video and for another 10 minutes for Q&A. So Pradeep, we will watch your video first.
Yeah, that will be
Second,
for 10 minutes and 5 minutes for question and answer.
oh yes, yeah, yes,
Thank you.
10 and 5. Sapunizam, over to you.
Sure. Hello, I'm Pradeep Singh Nalia, PhD part-time student at UTP Ipoh, Malaysia. I welcome to my presentation on GA approach to optimization of convolutional neural network. In the next slide, I will be showing you my presentation outline. Here's the flow of the paper. So I'll be first covering introduction, proposed methodology, detailed design of experiment for CNN, result summary, and finally conclusion. So as you can see, these days, deep learning has been able to outpace machine learning results in most of the scenarios, especially in image analytics and higher dimension problems. Mostly, we see the deep learning deep learning problems are related to optimization of weights and hyperparameter, which involves finding the best set to conclude what is the problem we have in hand. Typically, we take gradient descent for deep learning to optimize these parameters, and some of the issues we found in the gradient descent with that propagation, that they actually get stuck in one of the several optima or saddle points for complex functions, especially. And this is because of their nature, that they lack exploratory characteristics for searching in the optimization space in an efficient manner. Other thing we found was the derivative calculation on backpropagation are pretty heavy on computing resources. And this is further complicated by the higher dimension problems, especially in image classification. So for above region, we want to explore some alternate optimization methods like meta-heuristic algorithm, especially genetic algorithm in deep learning. And this is my presentation of implementation of genetic algorithm to optimize deep learning network. So merit and demerit of optimization methods, as you see, gradient descent is by propagation. They can always find a global optima provided the problem is simple. In another way, we can say is linearly classifiable. Also, with BPGD, there is a lot of dependencies on the hyperparameter tuning. The hyperparameter has a lot of impact on the output of backpropagation and gradient descent. Typically, if you know that the lower learning rate always takes a long time to converge, and higher learning rate will tend to miss the optima. So these are one of the several problems we face. Other than that, I already discussed, computationally it is very expensive because we have to derive, we have to calculate derivatives, and for a higher dimension problem, the derivatives could be increasing exponentially. Whereas when we optimize with meta-heuristic models, we found that for a simpler network, if the size of the problem we have in hand is easier and the inputs are smaller in dimension, that GA can match or can potentially outperform gradient descent
There
plus
is a background noise.
propagation.
Initially, it
On
was
the other
okay.
hand, if the
Can
size of
you?
the
Yes, it
network
looks like there is a
bigger, which is like the problem is
somebody's
complicated, then
need to go on
GA
mute.
performance we have found is like
Everyone
typically
should go
not
on
so
mute.
good. For these above reasons, we want to also look into meta-heuristic once more and see its ability to optimize deep learning, especially at a a higher dimension of inputs and complex problems. Next, we will focus on proposed methodology. As you see, we have it is in 3 stages. We'll have some data processing, then we will have a feed-forward correlation neural network, and this is then married to a genetic algorithm which will replace the backpropagation, typical backpropagation. Instead of that, we will use a genetic algorithm to optimize. As you can see in the right-hand side, you have a genetic algorithm, generic flow, where we initialize population, we do a fitness function is calculated, which is like a accuracy or something, and then we keep checking whether it is meeting the output result. If yes, terminate now, then we go for selection, the parent selection, crossing them over, mutating them, and then again checking for the fitness. This cycle keeps on going till we reach our objective. And let's see how this performs. Here we see a pictorially representation of CNN, and there it is this actually married here with a genetic optimization. This is typical 2D CNN for MNIST digit data set. And we consider this as high dimension for now. Because it's like input is 28 by 28, which is like 768 change, 64, yeah. Let's look at the result summary. As you can see, at the low dimension, what we see here is GD, gradient descent with ADAM, and 2 epochs can actually reach almost like 100%. And GD, whereas GA with CNN actually take a little while. Sometimes it is like taking around a 1,000 iteration or generation, specifically for GA, typical to epoch. And sometimes it takes like 166 when we have a different set of parameters here. So it is like 16 is the solution per population. Higher the solution per population, more exploratory power it has. And 4 is number of parents mating out of 16. And then 4% is actually the mutation. This actually can change. Like 166, we could reach 99%, whereas 7 generation, we can even touch 73%. But on the higher dimension side, we didn't find much of success like we found at the lower dimension, and that is where we want to explore a little further. And we saw GA has been very good, in terms of in its initial generations, it is rising very fast, steadily from 20%, less than 20% to 50, around more than 40%. It has been very fast, but as it reaches in a higher optimization space, it actually is maybe meeting several settle points or local minima. What conclusion we can draw is that GA has been completed, and but as the dimensionality of the input increases, GA seems to lose the battle. Further, we found mutation and even crossover doesn't help in the way it is right now. So we want to go ahead and try to give some guidance to the mutation in terms of which way to mutate, and so at a similar guidance we want to explore for crossover. So the parent selection for crossover is not at random, which is currently. It should be in a logical manner, so that its exploitative characteristics are also utilized, which is actually much more better in backpropagation, where it builds on its predecessor solution, and it keeps improving that. So which is actually missing in genetic algorithm, and that's what we are actually looking at. Yeah. So thank you for your time, and this is what we are going to do next, is looking into above conclusions, and this is the acknowledgement that this has been supported by a YUTP grant. And please reach out to me at this email ID. I sincerely thank you for your time, and should you have any question, we have 5 minutes. Thank you.
Q&A session.
It may come from the presenter, among the presenter, and also the listener. You can, I think, use the microphone, or you can put up the question in the discussion forum. Anyone? Any question? So Pradeep, well, maybe if no one want to ask question, then I will ask question. Any reason why you use GA as an approach to optimize the CNN? Why not other thing? The mic, please. The mic, please. Your mic is
Okay.
muted.
Can you hear me?
Yeah.
Okay, thank you. A very good question. Very logical. The only reason we started with GA was because a lot of research was already done in this space. So, so we wanted to start with something which is there already and build upon that slowly and slowly. Now, as we speak, we are doing a lot of background research, which are in a lot of other spaces other algorithms in terms of meta heuristics and even we are trying to get some statistical process by which you can create some guidance for mutation and crossover, which is currently is at random basis. So we are just trying to leverage something already done, and we actually even there also we could find something to work on. And other like bee colony and ant colony and movement optimization, all those things are being currently being explored, and we found a lot of promising results even on that side as we speak. And I'm actually almost ready for my journal publication in this, and we have found now even in the higher dimension space as we speak. But
Okay.
yeah, back to your question, GA, because it's easier to understand or compared to others which are less known or less published work. Yeah,
Okay.
thank you.
All right.
Thank you.
So maybe we just have 2 more minutes. Anyone from the discussion forum? Maybe one more question from me.
Please.
Okay. What is it that you are trying to optimize? Is it the speed, the performance, or is it the results that give you a higher accuracy? What is it that you are optimizing? Maybe you have
Okay.
mentioned that, but it was an interruption just now. I can't hear clearly.
Okay.
Yeah.
Very good question again.
Mm,
So we are clear. What we are trying to do is we want to have higher accuracy, but with the efficiency. Means
mm,
the number of generation should be, if not lesser than back propagation, but it
mm,
should be like similar, so that we can open doors in this space. Because as I was saying, back propagation has a limitation of exploratory characteristics. Means it
mm,
cannot explore the optimization space as well. Genetic algorithm and other meta-heuristic algorithm can. So that is one characteristics we want to expose to other researchers and ourselves, how we can leverage that. Mm, and So back to your question. So we definitely want a very good very good accuracy. Secondly, we want to have efficiency also coming in that. But I think that is going to be like a tough job for us.
mm.
That we have to bring not. I mean, then our current exploration into meta-heuristic will not remain just a meta-heuristic. It will bring
Yeah.
some logical, statistical basis. Yeah. Yeah.
Okay. All
Thank
right.
you. Yeah.
Well, it's exactly 12:20 now. We have to move to the next speaker, unfortunately.
Thank you.
So,
Thank you very
Pradeep,
much.
stay with us. You may pose a question after this. I think you are familiar with the system already,
Sure.
so it'll be good for you.
Sure.
So stay
Definitely.
tuned until the end of the session. So next speaker is going to be Mr. Rashid Hussain, Hamdard University, Pakistan, on solar wind hybrid energy generation system MPPT using perturb and observe algorithm. Okay. So let's start with the video, I think.
Hello everyone, my name is Dr. Ahmed Sikandar. I'm here to present a paper for my colleague as I'm not the main author. I'm the second author of the paper, named as Solar Wind Hybrid Energy Generation System, Maximum Power Point Tracking using Buttercup and Observe Algorithm. Here are some important points. We know that the traditional energy sources are the major cause of the pollution, which adversely affects ecology. This research focuses on the performance optimization of solar wind hybrid generation system. In this research, we have investigated the Wartrop and Observe algorithm for fourth and PV curves of photovoltaic cell. Wartrop and Observe algorithm is the industry de facto standard for optimization of PV panel power. The result demonstrated efficient battery charging by extracting maximum power point from photovoltaic cell. Introduction. The proposed system involves various calculation parameters including angle, sensors, quality cost, scope of viability, and temperature change. Maximum power point tracking algorithm is the computational technique used for better efficiency for photovoltaic applications. In case of PV exhibit is reasonably shaded, there are various maximum curves. To resolve this issue, attempt has been made. PV cell, photovoltaic cell is made up of semiconductor. Now we are defining the basics of the photovoltaic cell. Photovoltaic cell is made up of semiconductors. The solar energy when fallen into semiconductor material may result in the energizing particle. The equation is given as I is equals to IL minus I naught and so on. Here I naught is the situation current, Q is the charges, K are the Boltzmann constant, T is the temperature, and R cell and R Shu are the shunt and series resistance of photovoltaic cell module. These are the maximum power point curves for short circuit current scenarios. Here we can see the graph between current, voltage and power. As we see that the power is increased, the current is also increased with the decrease in voltage. These are the fill factors. In the PV module, fill factor is defined for the maximum power point together with the short circuit current and open circuit voltage as shown in the equation, which is given here. FF is equals to IV over IV. This is the radiance and temperature effect. Following equation shows the temperature negative impact with kV. It is also observed that with increasing temperature, voltage decreases, that we have shown you in the graph. This is the basic reason by which power reduction in photovoltaic module is observed. Here are the aerodynamics of wind turbine reasons. When it comes to wind turbine guideline, the disc of the wind turbine is connected to the normal driving shaft, which is attended to the generator power. The foremost common demonstrate for optimal design is the actuator plate. Demonstrate put out the Rankine floor. This show require a few greatly rearranging suspicious and however yields a number of valuable estimation comes out. Now we have using the two method, that is we have installed it in hill climbing and we have basically observed the two methods, that is the hill climbing method and Buttercup and observe algorithm. The simulation graphs are shown under using the different features. PV module we have used is of 50 watt and the ratings are 17.42. Current is limited to 3.11 ampere. Wind turbine is of 50 watt. Rating is 16 volt and 3.2 amperes. We have attached the load, that is DC motor LED of 3 amperes. Operating temperature is 25 degrees Celsius. These are the simulations where we can see that PV and I4 plot along y x-axis. It shows that with the increase of power, current also increases. This is the impact of photovoltaic cell generated current and voltage as shown in figure. This is the MPPT output and this is the hybrid output. In this research study, we have demonstrated and validated maximum power point tracking algorithm using photovoltaic modules, wind turbines, bus boost converter, voltage and current sensors connected to Arduino. During this research, maximum power point tracking was investigated under various environment conditions to measure optimal parameters. For further research, more advanced buck boost converter may investigate for better efficiency of the system. These are the references. Thank you very much for your valuable time.
Okay. Thank you very much, Rashid. And we have a 5 minute Q&A. Nizam, is Adin
Thank you,
ready?
sir. Are you getting my voice?
Yeah, I can hear you.
Yeah. Good to see you.
Just give me 1 minute. Yeah, I just want to make
Okay.
sure. Oh yeah, okay. Izadin is taking over.
Can you hear my voice?
Yes, we can hear you.
Yes.
Okay, great. So Dr. Kamil, you are handing this over to me. Oh, Dr. Kamil has left.
How are
Okay,
you?
so I open the floor for Q&A. Anybody who would like to ask questions, please do so. Okay, if there is no question, I would like to ask a simple question, more of
Uh-huh.
research direction. So, what do you think will be the recommendation of this research in the future?
You know that there are the efficiency of the solar and wind is one of the biggest channel. We need to go toward the most optimal part of the solar and wind. So it's not possible with the research in this domain. So in the future, we will see a more effective solar panel and wind for the more efficient production of solar energy. A lot of energy has been wasted in the form of the temperature losses and the losses of ultraviolet light. And so by this research, we will see more advanced techniques in order to get the most energy out of the sunlight.
So, another question from me, just for intuition, my uh, curiosity. How do we actually bring down the price of using solar energy? Because I think one of the obstacle of people not
Yeah.
using solar energy is because it is assumed to be expensive, right?
Okay, the very good question. If on the one technical side, if we produce high quality of the solar panel in a bulk, we will save lot of money. On the other hand, government and the international organizations should promote and gave relief in the form of exemption of taxes and promoting the adoption of alternate energy. So in this way, we not only we can have a lower pricing of this panel, but also we will see more institutionalization support from the government as well as the international agencies.
Okay, fantastic. So do we have any other question from the attendees here? Any participant? Okay, if there's no question, then I would like to say thank you very much to Dr. Rashid Hussein
Thank you.
for
So
your
nice of you.
presentation. Thank you.
Thank you.
Now, can we are now at 12:31. We are very good in terms of time. Next presenter will be Mr. Shankar Teo from University Tunku Abdul Rahman, Malaysia, with the topic of fast regression convolutional neural network for visual crowd counting. So without further ado, I would like to play the video recording.
Hello ladies and gentlemen, I am the presenter for the paper Fast Regression Convolutional Neural Network for Visual Crowding. My name is Teo Sheng Kang. I am from University of Laman. Let's get started. The outline from this presentation is I'll start with instructions, related work, proposed methods, experimental result, and lastly conclusions. So let's start with instructions. So for visual surveillance system that actually become more common and their deployment actually become more widespread as well become more complex. So from here you can see that crowd can be commonly observed in airport, bus terminals, tourist spot, and public exhibitions. So the issue of crowd control has emerged with the exponential growth of the world populations. Hence, the essential part of crowd control is crowd counting and actually received many researchers' interest. So the method used in the crowd counting has the detection-based approach, attempting to locate the accurate position of each human object. It has a trained detectors, which is head detection and face detections. However, this method did not perform well in complex scene because it can't actually tolerate with the change of perspective. You have various illuminations and severe occlusions. So hence, another method is called regression-based approach. It's either regress the number of human objects directly from the image instead of searching or predict a destiny map. So what is meant by destiny map? You can see from the picture. A destiny map represents a special distribution information from the image. So with the success of CNN in solving computer vision problems, many researchers are inspired and starting to harness the ability to generate a quality destiny map and eventually estimate an accurate count. So from the picture, you can see that this is called multi-column convolutional network. So another factor that will affect the prediction accuracy of the CNN model is the inference methodology. We have two here. One is called patch-based inference, and the one is called whole image-based inference. So in the patch-based inference methodology, the CNN model is trained using a small image patch from the input image, and actually crop size depends on the image used. So you can see from picture. So during the testing phase, a sliding window is slide over the test image, and crop estimation are obtained from each image. And lastly, all the individual count were summed together to obtain the total count. Okay. In contrast, in whole image-based inference methodology, feature will be learned and tested directly from the whole image instead of using a sliding window. So this method actually avoids computational expensive sliding windows. So research work from this author actually observed there's an increase of prediction accuracy and the increase of inference speeds by using whole image-based inference. So for related works, so for the detection-based, this author hasn't actually proposed a method to compute the HOG, okay, image features from the image and count the human object by using super-weighted machine. Then another two authors actually use fast detections, okay, to count the number of detections. So this categorized under detection-based. Okay, after that, for the regression-based, this author Chen, Corte, and Deng actually extract the useful feature from the image and combine with the regressions methods, which regressions support vector regression and Gaussian progress regressions are used to count the crowd. Then the author used the CNN model, okay, actually adopted the LastNet, okay, the author Wang actually adopted the AlexNet and designed end-to-end deep CNN regression model. And more complex model is proposed by this author Chang, is using multi-column network, okay, to generate a destiny map and from there count the crowd. Then for the inference methods, right, for Chang is using multi-column, he is using patch-based inference methodology. Then for Shang, for the end-to-end crowd counting, okay, is actually using the whole image-based inference methodology. And lastly, from this author, okay, Vismaran, actually observed that there's a reduction of complexity, okay, while when you are using whole image-based inference methodology, because the computation are actually shared on the overlapping regions. So with that, right, I found that multiple stages of processing and complex structures are needed to output a predicted destiny map, and the CNN model that predict the destiny map usually require an extra step, which is a ground truth generation, and also the patch-based inference is actually computation and complex. Therefore, the newly proposed fast regression convolution network is built on these agreements. Let's see the proposed method. So these are the network overview for my proposed method. So the aim of this paper is to design an effective end-to-end regression CNN model to learn the useful feature in a relative easy and direct way to predict the total count from the crowd image. From the network, you can see that there are actually 5 convolution layers. So by using the value activation function, there are another 5 fully contained layers. Okay, is actually using leaking value activation function. Okay, the last layer is actually is a single regression node that is used to predict the crowd. So for this one, it's actually using the whole image as the input instead of using multiple batches. So to train the model, I'm using Adam optimization algorithm. Okay, all the network weights are actually initialized using Calvin weight initializations. Okay, the learning rate is set to 0.001. MSE loss mean square error loss function is estimated to measure the loss between the ground truth and estimated crowd. Then to avoid overfitting, a crowd layer is also applied. So with these hyperparameters, the model actually reach a better local optima at 50 pops. So the dataset used to train and test the proposed method is actually called more dataset. So this more dataset contain relative high static and moving crowd density. I have a severe perspective distortion and severe occlusions. So we have a total of 2000 frames with a size of 320 times 240 resolution. So I divided into 3 sets: training set, validation set, and testing set. So the number precision range from 13 to 53 per image. So to evaluate the model, okay, I'm using MAE and MSE. So why I'm using this model? Because this the evaluation machine mainly used to evaluate the regression problem. So you can see from the this formula actually adopted by the researcher as well. Okay, so in general, MAC denote the accuracy for the model, and MSC denote the robustness of the model. Okay, so from this one, since it's an error, so lower score indicate that the network have a good counting performance. So the result, okay, by using all the result and all the hyperparameters and also all the training sets, testing set and validation set. So this proposed method actually achieved MAE of 2.14, MSE of 8.53. Okay, I also benchmark with a different set of art approach. So you can see from the table, our network actually achieved lower MAE and MSE. Okay, from the graph, you can see that the predicted result also close to the ground truth as well. So I also further tested and analyzed the proposed network with the error rate distributions. So with this formula, you can see from the graph, it's actually concentrated at the negative 0.1 and 0. Okay, 0 means that there is no error. Okay, so you can see it actually concentrates this, which means that it actually has a less error. So I also do further testing on the proposed network because I want to see whether it have a very low latency or not. Okay, why? Because deployment of low latency crowd counting model, they can be operated in real time. Okay, it's also another insertion issue and actually seldom addressed by the researcher. Okay, so with the invention and affordable, powerful edge model, so many computer visions are actually deployed at the edge side already. So, but how do we know that whether it's accepted by the end user or not? I'm using mean relative error. Okay, so according to this author, so if the model have the mean error of 20%, it will accept by the end user. So actually, test the proposed methods in the NVIDIA TX2 board. It actually achieved the execution speed of 1.2 seconds and also MIE at 6.39 which is lower than 20%. So these are the references used by these presentations. So lastly, for the conclusions, in this paper, a deep regression CNN architecture for visual crowd connecting is proposed. So the proposed network architected with convolution layers, fully connected layers, and lastly, regression nodes. So the inference methodology that affect the performance of the crowd connecting network is also analyzed. So I also do some comprehensive analysis and tests. Okay, and I also conclude that the model achieved MAE of 2.14, MSE of 8.53, and MIE of 6.39. Okay, I also deploy an embedded system to test whether it has it can actually do can be run in real time or not. So it actually achieved 1.2 seconds of the per inference speed. Okay, so finally the experiment result also demonstrate the proposed network achieve a good performance. So with that, thank you.
Well, thank you very much, Mr. Shenkang Teo.
Yes.
I open to the floor if there is any question to be asked. Anyone who would like to ask question? Okay, I have a very simple question, Mr. Sheng.
Yes.
I was wondering whether this application has been tested on a motion type of image rather than still image. So maybe you have some insight into that.
You're asking whether it's dynamic or the static image, is it?
Yeah. Yes. Yes.
The more data set is actually more towards is the static image. So, but all the static image they are actually linked together. So they actually capture in frame by frame, okay, in the real time. So in other words, it's actually some sort of tested in dynamic images as well. Okay, and then I think there's some questions from the question how you train. To train this run, I'm using the PyTorch framework to actually train my network. Okay, and then with the three sets, which is a testing set, training set, and validation set. And then for the training sets is mainly for training purpose. Then from there, I will tune the parameters for the validation set. Okay, then because why I have the validation set, because I don't want the hyperparameters is actually trained towards the no, it will affect the result. So that's why I have a validation set, okay, to test the hyperparameter trainings, and then lastly only test with the test data, which is the out sample data.
Okay. Yeah, so there's another question by Mr. Pradeep Naulia. How does the training data look like, features and target? So
okay,
maybe...
the features is from the, it's actually using the CNN to actually extract the features from the image. Okay, then the target is actually the crowd size. That's the target. Okay, and then you're asking how do you configure the training data. I think just now I already answered these questions.
Okay, if there is no more question, thank you very much, Mr. Sheng.
Okay, thank you.
All the best in your future endeavor. I would like to call upon the next video. The next video is a paper together with Associate Professor Dr. Ahmad Kamil with the title of Share Buyback Prediction Using LSTM, Long Short-Term Memory on Malaysian Stock Market. So may I call in the presenter? I think the presenter is Mr. Zahid, am I right?
Assalamualaikum warahmatullahi wabarakatuh and very good day. My name is Muhammad Zahid bin Hilmi. I'm from University Technology Petronas, and today I will be presenting about on share buyback prediction using long short-term memory on Malaysian stock market. So this will be our outline for today's presentation. We will start with introduction, problem statement, research objective, followed by related works with the proposed solution. And from there, we will be laying out the research methodology, the results, next step moving forward, and as for the we will end with the conclusion. So what is share buyback? Share buyback is an act of buying back available shares on the market. It happens when the share values is undervalued. So when company decided to buy back its shares, this indicates that the company is doing well in the market. Higher number share available outside company hold equals to higher dividend payment to outside investors. So when they decide to buy back, they can reduce equity finance costs, capitalize the undervalued shares, and consolidate ownership. So what are the problem statements? The first one is predicting share price based on historical data may not project the same output in real world cases. Share price has many uncertainties due to internal and external factors that can affect the prediction of the next share price movement. So as for the research objective, the first one is to investigate the trend of share buyback strategies or decision as practiced by companies. Second one is to design a prediction model in relation to the share price movement during the share repurchase event period. The third one is to study which parameter has the most influence on share price movement. And the last one is to predict share price movement that will initiate buyback action. So this is our related works. The first one is uh, we will learn why company decided to buy back their shares. First one is to reduce available outstanding shares, to reduce dividend payment, to increase earning per share, to show that the company is doing well in the market, and to eliminate any threats by shareholders who might want to control the stake. As for the stock analysis, it is divided into three sections. The first one is the fundamental analysis. The second one is the technical analysis. And the last one is the trend patterns, which can be divided into pennants, flag, and wedge. For the most used stock indicators, according to research, the first one is the relative strength index. The second one is the moving average conversion divergence, MACD. And then the last one is the exponential moving average, EMA. And as for the most used data, according to research, the first one is the highest price. Second one is the lowest price. The third one is the opening price, and the last one is closing price. So as for the related works, based on the research prediction algorithm, we found that according to Vargas, RNN, recurrent neural network, is a good choice of prediction model. It can get context and model complex temporal characteristics. However, we found that LSTM is a better version of RNN, which it has the ability to reduce vanishing gradient. According to Kameni 2019, they found that LSTM is better than support vector machine and back propagation in terms of prediction accuracy. And according to Abdoli, they found that LSTM is better than auto-regressive integrated moving average in terms of prediction performance. As for the proposed solution, we propose that the use of long short-term memory, LSTM algorithm, as the prediction model. We want to multiple input with multiple neural networks for better prediction of stock price movement. The use of historical data to develop the prediction model. The use of supporting data such as technical indicators and news on Asian companies buyback. And the last one, we will be comparing all the different case studies with each other to find the best case combination. This will be our research methodology. We'll be starting with finding the historical data. So from there, we'll be doing the data preparation, such as removing all missing data. And then we'll be developing the prediction model with the supporting data, which is the stock indicators with and also the Malaysian news on companies. And then we'll be training the model and test the model to see whether the model is optimized or not. If the model is optimized, we'll be move to the next step, which is compare the accuracy and also the performance. So this will be the end of this research methodology. So how we decide to choose what company to be in this research. The first one is the company needs to be listed, public listed company. Second is it needs to be listed in Bursa Malaysia. The third one is the company should be regulated by Security Commission Malaysia. Fourth one is the data should be available in Yahoo Finance. And the last one is we'll be choosing three types sizes of companies, small, medium, and large, to find to analyze the data on why they buy back. As for the data collected from Yahoo Finance, we will collect the date, opening price, closing price, highest price, and the lowest price to fit to develop the prediction model. As for the prediction model setup, we divided the training to testing ratio to 80 to 20 training to testing. We divided into 50 and 100 epoch size, and also we divided into 3 hidden layers. The first one is the single, second one is double, and the third one is quad layers. From there, the output will be validated using MAE, MSE, and R squared. So this is the result with 450 epoch with multiple layers. As we can see here on the green table, open parameter had the highest prediction accuracy, followed by the double layers, which is in blue table. Also has the highest prediction accuracy using open parameter, and also followed by the quad layer on table orange. However, with 100 epoch, we found that only single and double layers had the highest prediction accuracy. But for the quad layers, we found that low parameter and close parameter had the highest prediction accuracies. As for the conclusion, we found that single layer performed best with 50 epoch and also 100 epochs with 99% accuracy in less than 5 minutes of processing time. We also found that as the number of layers increases, the prediction accuracy will be reduced. And moving forward, what we want to do, we want to add more training to testing ratio option instead of only 80 to 20. We want to add more epoch size option, such as 25 epochs. We want to add more supporting data into the setup and run more experiments to instead of only one company. As for conclusion, predicting stock market price is very challenging. Choosing the relevant data or parameters might be challenging. Long processing time might convert to loss since stock price always fluctuates, and using prediction model as one of the tools for stock price movement is possible. So this will be the end of presentation. Thank you.
Very much, Mr. Muhammad Zahid. I believe Dr. Kamil here is ready to take question. So if there are any question from the floor, maybe you can put it in the discussion or maybe voice out. Okay, if there is no question, I do have a simple question for the presenter and Dr. Kamil. I was wondering why is it LSTM but not other type of deep learning method being used? Can I hear you, Dr. Kamil?
I think it's not because we have done the exhaustive comparison with other methods. So with the limited time that the student have, so he just based on a number of journals which talk about LSTM and also the RNN, and of course there are many other methods like in the statistical method, they got a random walk model, they got a time series model. But I think the student, didn't actually compare with the others. So LSTM was chosen merely because of some of the journals article. They have done a similar research with a similar objective, I would say, in terms of performance and simple data with like only 4 types of data: the closing, the opening, the high, and the low. So if we factor in more data, then maybe other model may show a good example. And the number two is, see, buyback is not something that you do daily. No, when the company have the money and they look at the market and their share is, undervalued seriously for a number of days, then they might consider buying it. But buying just to rescue the reputation of the company, that's the intention. So it's not like investor they may touch and go, they may buy and sell in the afternoon. But for company, it's a matter of reputation of the company. I mean, you can look at, say for example, Asia, for example, and a number of company which rock bottom price, and it doesn't reflect their fundamentals. Their fundamental maybe the accounting, the reserve, the financial that they have, maybe good enough to sustain for the next few months or years, but the price doesn't reflect that. And number three is, to buy is not easy for a company that own that share, because they need to get consent from the board as well. So they cannot just simply buy. Two reasons. One is because the money could have been used for R&D, for example, rather than rescue the share. And number two is probably they give to the staff as in the form of bonus. So when they spend here, then they got to cut bonus maybe, so which the workers doesn't like it. And this is happening in US, in UK, in all over the world. So again, why we choose LSTM, I think, is simple, and it is use less resources, I would say, and the student have done quite a limited comparison. So it's nowhere, it's not exhaustive enough, I would say. Thank you for your question.
Thank you very much for coming. I think that is fair enough. Thank you for the presentation. Thank you to
Okay.
Mr. Muhammad Zahid.
Yeah.
So I guess if there is no more question, I would like to call upon the next presenter.
We are ahead by 3 minutes, I think, right?
Yeah, I think we
Or
are
5
ahead.
seconds
Yeah.
ahead. Yeah. Okay, thank you.
Thank you, Doc.
Thank you.
So our next presenter is Mr. Ahmed Sikandar from Hamdard University, Pakistan, with the paper titled Application of a Wavelet-Based Krylov Subspace Algorithm on Digital Signal Convergence. So without further ado, I would like to call upon the presenter.
Hello and good evening. My name is Mohammad Ahmed Sikandar. I'm from Hamdard University. I'm here to explain the paper that is application of a wavelet-based Karlov subspace algorithm on digital signal convergence. The agenda items are the introduction, and we will discuss the problem identification. After that, material and methods, in which we will discuss the algorithm, the components of the algorithm, then the result discussion, conclusion, and inferences. In today's world, digital transmission has its importance not only because of speed and accuracy, but it also includes error-free and rapid communication. These things are only achievable by using different techniques and methods which are based on theories built upon the branches of applied science and engineering. In this research, an algorithm is presented by sequentially combining two great transforms, that is wavelet and Karlov. The algorithm was formally developed by the author as PhD work and is known as WK algorithm. So first we will define what is basically the problem is and how we want to give an output of the solution. In going to the literature review, it reveals that the digital communication, one of the main issue is the wireless transmission is the convergence of the signal. which means that the received signal should be the same as the signal which has been sent. The convergence defines the signal reception in terms of pattern, nature, and amplitude. The literature also exposes that convergence issue arising mainly from the two main constraints that are eigenvalue spread and sparse identification. Eigenvalue spread is defined as the ratio between the signal higher and lower eigenvalues, and sparse is defined as the number of indefinite values in the function which is defined by for the signal. These two constraints can be used to fasten the convergence plus to make also used to make the communication error free. Basically, we have designed an algorithm that is called WK algorithm. In the WK algorithm, two main tools have been used, which are the mathematical powerful tools named as Wavelet and Karloff. This is also my PhD work, and this paper is the extension of that work. As this is mainly developed with the wavelet transform and Karloff subspace, we will need to define what is basically the wavelet transform and Karloff subspace. Wavelet transform is a powerful mathematical transformation of a signal which decomposes signal into higher and lower frequency components known as approximation. And Karloff subspace is a subspace sequence which generates subspaces of the given signal in form of mathematical sequence. After the preconditioning of the signal with the wavelet transform and Karloff subspace, the LMS FIR filter is used to convert the signal with reference to the reference signal or the desired signal. These are the equations which are used to develop the WK algorithm, in which this includes the equations from this generation of the signal till the convergence of the signal using the LMS FIR filter. The equation number one is used to define the signal. Then the signal has been transformed using the wavelet transform. Then the correlation has been established in order to convert the signal to the Karloff sequence. Then this Karloff signal is being fed to the FIR filter in order to convert the signal with respect to the reference signal. These are the results which have been given for the data 500 data points, and it has been compared with the traditional algorithm, that is wavelet and Karloff separately. The data points which are used are the 500 data points. Detail modulation that has been used is the BBSK. Noise channel is used as the AWGN. Discrete wavelet transform is used, and the simulation last 6 bits are used to compare the result. This is basically the validation of the result, in which a graph shows that the last 6 bits that has been sent are having these values, in which Karloff only gives the output with the error, as same as the wavelet only gives the output with some little error, but our algorithm has basically give the same output that has been received, that has been sent, and it gives us the same output after the transmission. So it defines that, it concludes that the algorithm basically uses BD. It defines that our algorithm has worked perfectly in the given scenario. These are the references. Thank you very much for your time.
Thank you very much, Dr. Ahmad Sikandar. So do we have any question for the presenter? We will post it here. Okay, I would like to proceed with our next presenter. by Morgana Vadivelu with the research topic of superlinear speedup on GPU using Laplacian algorithm with convolutional filtering as a case study. Without further ado, I call upon the presenter.
Good day, everyone. I'm Morgana Vadivilu from University Tunku Abdul Rahman, Utah, Malaysia. This is my paper presentation in Iccoins with the title of Superlinear Speedup on GPU using Laplacian algorithm with convolution filtering as a case study. So moving on further, the main aim of this study is to evaluate the hypothesis that when the threads are assigned with heavy workload in GPU, superlinear speedup is observed. So what is actually superlinear speedup? In parallel platform, superlinear speedup that obtains or the speedup that obtains a greater value than the number of utilized processes to execute an algorithm, that particular speedup is known as a superlinear speedup. That means, in short, if the speedup value is higher than the processes we're utilizing to run or execute an algorithm, that particular speedup is known as a superlinear speedup. So, in line to evaluate our hypothesis, in this work we have used image convolution filtering algorithm as a case study. So since there are many variations of image filtering, convolution filtering algorithm that are available, in this work we have used Laplacian algorithm. So moving on further, so why did we use image edge detection algorithm with convolution filtering? Is because in this algorithm we have convolution filtering that are known as kernel. So these kernel are in 2D or in 2 dimension where they vary in sizes. For instance, 3 by 3, 5 by 5, 7 by 7 for instance. So they work as a spatial filter that producing a range of effect for a particular pixel in an image to identify whether the particular pixel is an edge or non-edge pixel. So how it works is that this kernel will try to determine a new value for a particular pixel by considering or adding the weighted values of its neighboring pixels together. So this process is repeated for every pixels that are found in that image, finally producing a gradient image as an output. So this gradient image has details, has the edges of the objects that are found in the image. So this is how generally the algorithm works. And here we have actually programmed the algorithm in a way which the image uh, is in 1D array, while the kernel are defined in 2D array. And the algorithm will work according to the Laplacian algorithm, where the mathematical equation are imposed onto this. According to the Laplacian equations are imposed in order to calculate the gradient value for each of the pixel and finally generating the gradient image. So this would be the general skeleton or general pseudocode of the sequential algorithm that we have programmed or coded. So as going further to the related works, these are the list of existing works that we have studied or reviewed. Mainly this existing work are trying to improve the speed up of the sequential algorithm on GPU architecture. None of them are having any variations on the kernel sizes because their main aim is just to improve the speed up of the convolution edge detection algorithm. So each of them have worked on different types of edge detection algorithm, for instance, Caney, Robert, Laplacian, Sobel, and Gaussian, and they have standardized the kernel size to one size in order to see how much speed up are they increasing based on their proposed algorithm, proposed parallel algorithm in comparison to the sequential one. But we could not find any related work to our hypothesis where they are trying to vary the kernel sizes. So that is why we had to report this existing work as the related work to our study. So moving on further on the proposed algorithm, we have coded the algorithm using data parallelism technique. Before that, this is the general skeleton or the pseudocode of the algorithm. So we have defined the image in 1D similar to the sequential algorithm and the kernel in 2D dimension array. So there are no difference in defining this as per the sequential and also the proposed parallel algorithm. But the only difference between our proposed algorithm and the sequential one is that in the parallel algorithm, we have used data parallelism technique whereby each thread is assigned a pixel to carry and to execute the instruction related to the Laplacian edge detection algorithm. So that means for each pixel, we have assigned one thread. So this thread will run concurrently to perform the instructions or steps required in the Laplacian edge detection algorithm. So the image pixels here are transferred from CPU to GPU, which is the device by these threads, to execute the instruction. In line with this also, the convolution kernel that we defined, we have in this algorithm, we have defined it in the device local memory. That means we have defined it in the GPU local memory. Why we have defined it in the local memory is because the local memory is fast and we want to utilize its low latency in order to increase the speed up of the proposed algorithm. So this is why we define the 2D kernel, convolution kernel in the GPU local memory. So the difference between the sequential program and also the coding and also the proposed parallel coding is that in parallel we have used data parallelism technique whereby the TID here, the thread is actually carrying, each thread is actually carrying the pixels that are found in the image. And apart from that, we have defined the convolution kernel in GPU local memory in order to increase the speed up of the algorithm. These are the differences. So in line to test the sequential and parallel algorithms, the sequential we have carried out the experiment in two platforms, and while the proposed parallel algorithm we have carried out in AMD Phenom processor in Linux kernel, and we have used NVIDIA Tesla GPU card with 448 scalar processors. And to generate the communication between CPU and GPU, we have used CUDA language. So moving on further, in terms of dataset and evaluation metrics, we have used Berkeley dataset, which is a publicly benchmarked natural image. And the evaluation metrics that we have used is dice and also speed up. So what is actually dice working as is that when the segmented results of both algorithms are identical, the dice or DSC will give a value of 1. So what we are doing here actually, the segmented result of the sequential algorithm is behaving or is treated as the gold standard, and with the segmented results, we are trying to compare with the segmented results of the proposed parallel algorithm. So if they are identical, we may get the value of DSC as 1. So from here we can see that these upper rows are the segmented results of the sequential algorithm, and the bottom one are the segmented results of the proposed parallel algorithm. So this is for 3 by 3 kernel, 5 by 5 kernel, 7 by 7 kernel. So we can see that each of these results are identical and they are giving the same values, which dice value as 1. So in line with this, you can see that for kernel size 7 by 7, we can see a lot of details in that image. That means we understand that when the kernel size is high, the algorithm or the thread of each pixels are carrying a very heavy workload. That's why we can observe a lot of details, edges details in that image. So in line with this, we can see in this graph for speed up, especially when the data set is growing, is getting larger, we can see the kernel with 7 by 7 is reaching a superlinear speed up, which is having more than speed up of 448. So 448 is the processor that we are utilizing, and we can get the speed up value higher than that for both platform of sequential 1 and sequential 2. by comparing the proposed parallel algorithm. So in line with this, we can conclude that when the kernel size is large, a superlinear speedup is being observed. So when the concurrent threads are carrying heavy workload, we may achieve a superlinear speedup.
Okay, so I believe that is the end of presentation, Dr. Morgana.
Yeah, yeah, I couldn't
Yeah.
finish reading that.
Okay.
So I forgot to say thank you.
Okay. Thank you, Dr. Morgana, for the presentation just now. So I open the floor for any question, if there is any. Let's take a look at the chat. Um, Okay, if there is no question from the audience, I do have some basic questions. 'Cause I'm not from the area of CNN. I was just wondering that how does the algorithm selects the matrix, whether it's 3 by 3 or 5 by 5, or how does it actually select the matrix in order
The
for the product?
conversion kernel is it?
Yeah,
We need
yeah.
to define it to the algorithm, whether we want to go it by 3 by 3, 5 by 5, or 7 by 7. So
Okay.
yeah, when it's 7 by 7, we are getting a lot of gradient between a lot of age details of each object that are found in the image. So that's when we are forcing more workload for each of the thread in GPGPU to carry and to do the instructions.
Mm. Then it could be a research topic by itself, to have something like a adaptive matrix selection, or
Yeah,
it
possible.
could be.
Because we are now working on the preliminary work. Our idea is that to find how much local memory in GPGPU can influence in getting a superlinear data. So that's when we started using convolution filtering because we can vary the sizes of the kernels.
So another question is that I saw in the result graph that you showed just now, at
Mhm.
one point, the result become stagnant or not no more increase, right?
Mhm.
So maybe can you explain a little bit why is that so? Why does it arrive to such a saturation point?
Because we have already utilized the maximum workload for each thread, especially when the data set size is very large, 10 by 1024 by 1024. It's a very large image. So we have already utilizing the maximum workload for each thread to run and execute the instructions. So at one point when the large data set is growing, it's already being saturated. So there's no more speed up we can observe.
Hmm. Okay. So I think yeah, there's no more question from me.
Thank you.
Yeah, thank you very much for the excellent presentation. I would
You're
like to conclude the overall session for track 1, computational intelligence. We have actually listened from 6 presenter since 12 o'clock. Thank you very much, Dr. Ahmad Kamil, for assisting me on the first half. I would conclude that all of the topic presented are very much worthy on its research contribution, and has a lot of potential to continue on. I can see the high standard of research carried out by all of the presenter, and has a lot of potential to further into other areas of research. So I would like to say thank you very much again for your participation into IC Coins 2020. And on behalf of the organizing committee, thank you very much again, and we would like to see you in the next IC Coins. So that will be all from me, Dr. Izzat, as a session chair. Thank you very much. Over to the host.
Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Good morning and good day, everyone. It is a pleasure to welcome respected speakers, delegates, and participants to the International Conference on Computer and Information Sciences, or Iccoins 2020. The Iccoins 2020 conference aims to discover the sustainability impact and challenges of Industry 4.0 with its main pillars such as the Internet of Things, big data analytics, cyber physical systems, and cloud computing on the developments of digital technologies and solutions for sustainable future. Thank you for tuning in to our Iccoins 2020 organized by the Computer and Information Sciences Department UTP and co-organized by the University Tunku Abdul Rahman Utah Perak Malaysia, Hamdard University Pakistan and Universitas Muhammadiyah Prof. Dr. Hamka UHamka Indonesia with the theme Sustaining Tomorrow with Digital Innovations. We have received around 150 papers from all over the world, and 75 papers finally have been accepted and will be presented in 4 different tracks throughout these 3 days of conference. The tracks for our conference are computational intelligence, cybernetics, software engineering and applications, and finally, informatics. In this conference, we're going to have 2 prominent speakers as our plenary speakers. They are Datuk TS Dr. Haji Amiruddin Abdul Wahab, the CEO of Cybersecurity Malaysia, and Dr. Etikan Kandasamy Karupia, the Director of Developer Ecosystem at NVIDIA Southeast Asia, who will be sharing their insight, knowledge, and wisdom on the most recent innovations and concerns as practical as challenges in the developments of digital technologies and solutions for sustainable futures. During this virtual conference also, you will be able to explore the following features in the virtual ESCON 2020. First, the virtual exhibition booth where you can actually interact with our exhibitors, the resource gallery where you can download all the materials that have been uploaded onto the platform, virtual tour where you can actually get to know our university better. We also have the integrated gamification functions. Here, we encourage you to be proactive, especially to gain more points. And finally,